going to explain about the introduction for this video. First of all, acid-base titration and neutralization. This titration is used to determine the unknown concentration in a certain substance with one of the concentration is already well known. At the end of the titration, the color change from the result observed, the indicator, the pH meter and the electrical conductivity can be known as a neutralization process. This process can be used and applied in many aspects and concepts. Next, what is neutralizing wastewater? Acid-base titration concept is used to neutralize the wastewater that contain volatile fatty acid. By using the titration of the acid and base concept, the problem of wastewater can be solved. Three examples of neutralizing wastewater aside from titration of an acid base are steam distillation, gravimetric method, and chromatography.
And now I want to discuss about application in water treatment. This process began by determining the type and concentration of the acid or base present in the wastewater through titration with a standard base or acid solution. And then the precise amount of neutralizing agent is needed, such as sodium hydroxide and sulfuric acid. The neutralizing agent is then added to wastewater, causing an acid-base reaction that produces acid and water. And then, during the titration, the pH of the solution is closely monitored to determine the equivalence point where the acid and base are completely neutralized. The pH at this point will depend on the strength of the acid and base involved. If needed, additional neutralizing agent can be added to adjust the pH further into the desired neutral range. And then, after neutralization, any precipitate such or methyl hydroxide may need to be removed from the water through filtration before the treated water can be safely discharged. For example, water softening. In water softening procedure, acid and base are used to eliminate minerals that can lead to scale accumulation, such as calcium and magnesium. And another example is disinfection. Acidic chlorine compounds are frequently used to disinfect water by eradicating dangerous germs and diseases.
Next, pH adjustments. Acids and bases are used to adjust the pH of water to optimal levels. For instance, acids like hydrochloric acid can be added to reduce pH, while bases like sodium hydroxide can be used to increase pH. Other than that is corrosion control. Acid-base chemistry is used to create a protective layer on pipes and infrastructure, preventing corrosion and ensuring the longevity of the water treatment system. Lastly, flocculations. Acids and bases help in flocculations, where impurities and water clump together, making them easy to remove through filtrations. This process involves the use of coagulants, which are often acidic or basic compounds.
Next, we will discuss about the methodology. The experiment involved by titrating a water sample with a standard sodium hydroxide solution. But before we run the experiment, we must collect the sample first. So the sample is taken from the river by using the depth sampler. The sample is collected at the surface, middle, and at the bottom of the river bed. So, the objective of this experiment is to determine the acidity of the water sample. The indicator we use in this experiment is phenolphthalein and methyl orange to determine the endpoint of the titration. The first step is we must prepare 0.1 molarity of sodium hydroxide solution. So, how to prepare the solution? By weighing 4 grams of sodium hydroxide by using analytical balance, and then we dissolve the sodium hydroxide in volumetric flask, and we swirl the flask gently to dissolve the sodium hydroxide completely, and then we dilute to the mark. Once the sodium hydroxide is fully dissolved and the solution has been cooled in room temperature, we must fill the flask with distilled water up to 1 liter mark. And then we mix the solution by inverting the flask several times to ensure the solution is thoroughly mixed. And then, the last one, we must label the solution as sodium hydroxide solution. The second procedure is measure 15 ml of water sample and transfer it to the Erlenmeyer flask and add a few drops of phenolphthalein. Next, the third procedure is titrate the sample with the standard sodium hydroxide solution until a faint pink color persists. Then, record the volume of sodium hydroxide used. The fourth is add a few drops of methyl orange indicator. Continue titrating until the color changes from yellow to orange. The last procedure is calculate the acidity of sample based on the total volume of sodium hydroxide used and the sample volume. The conclusion from this experiment is the acidity of the sample is determined by the amount of sodium hydroxide required to neutralize the acids present. The phenolphthalein endpoint indicates the presence of strong acid, while methyl orange accounts for both strong and weak acids. Precautions are needed when handling the samples and reagents, as colored or turbid samples presence of dissolved gases and interfacing ions can affect the titration. The experiment provides a quantitative method to measure the acidity of water sample, which is important for water treatment and environmental monitoring.
Next is a conclusion. Volumetric analysis is widely used in the field of analytical chemistry to determine the concentration of various compounds in food, environmental, and pharmaceutical samples because it provides a precise and accurate method for determining the concentration of unknown solution. The method can be used in the various industries to ensure the quality of the products and to monitor the levels of pollutant in the environment.